Okay, this is Math 105, Section 7.3. We just want to look at a couple things in the section. We're going to look at double angle formulas really quick and then half angle formulas, and I just want to show you where they come from. So for double angle formulas, we have sine of 2x where we're doubling our angle x, and that's just 2 times sine of x cosine of x. So let's say x is 50, then 2x would be 100, right? So sine of 100 would be 2 times sine of 50 cosine of 50 degrees or whatever. Okay, I just want to show you where that comes from. 2x is x plus x, right? So if we use our sum formulas where the first angle is x and the second angle is x, then we take, remember for our sum formula, we take sine of the first times cosine of the second, well the first and the second are the same, plus cosine of the first times sine of the second, and they are the same as well. So this is just sine of x times cosine of x twice. It's just that we have the order reversed here, but it's still sine of x times cosine of x, which gives me 2 sine of x cosine of x. So that's how we get that double angle formula for sine of 2x equals 2 sine of cosine of x. Okay, so there's our double angle formula for sine. For cosine, similarly, we can do the same thing. Now we're doing a sum formula for cosine. Remember, we take cosine of the first times cosine of the second minus sine of the first times sine of the second. Well, the first and the second are the same. So this is just cosine squared of x minus sine squared of x. So that's how we get that other formula for cosine. So cosine of 2x, which is the same as cosine of x plus x, is cosine squared minus sine squared. These are just derivations on those using our trig identities. So if you don't remember cosine squared minus sine squared. But again, I won't make you memorize these, but show that they're easily derived from our sum formulas, right? Just use x plus x because we're taking 2x, right? And same with cosine. Okay. So recognize that we can derive them very easily. Okay. We'll look at an example of a double angle formula application in class. We won't do it on this lecture. Okay, and the other thing we'll look at in the section is half angle formulas. I won't worry about tangent, we'll just do sine and cosine. So let's say we're taking an angle u and we want to look at half of it. Let's say u is 30 and we want to look at 15, so u over 2 would be 15. So sine of u over 2 is 1 minus cosine of u over 2 square root, plus or minus. Okay, and then the cosine of u over 2 is 1 plus cosine of u over 2 square root, plus or minus. Now the reason we have plus or minus is because if let's say our angle takes us into the second quadrant, or maybe our angle takes us into the fourth quadrant, we have to check the sign of what the half angle takes us into. Okay, so we got to look at what our original angle was and see where the half angle takes us, because we don't know for sure. Could take us into negative territory for sine or cosine. So that's why we have the plus or minus there. It also becomes that way from the derivation, but we won't worry about that. Okay, so let's look at a couple of quick applications of that. Okay, so let's say we want to the sine of 22.5 degrees. Now, we don't know that normally, right? But it is half of 45, okay? So we can use our half angle formula where u is 45, okay? So the sine of 22.5 is the sine of 45 over 2, so our u is 45. And following our formula, that's going to be plus or minus. Let me put the plus or minus there just so we have it. I can see how it's applied, okay? So we have 1 minus cosine of 45 over 2, because our u is 45. So it's 1 minus square root of 2 over 2 square root, right? Okay. Cosine of 45 is square root of 2 over 2. Okay, now just to simplify inside that larger square root, remember we had 1/2 of 4, so we can, if we make a common denominator of 4, we have 2 over 4. And remember we had square root of 2 over 2 divided by 2, so that gives us square root of 2 over 4. So we can just simplify that as a single fraction. Okay, and then we can take the 4 out in the denominator because the square root of 4 is 2, right? So this would be 1/2, not, because it's in the denominator. So be 1/2 times 2 times the square root of 2 minus square root of 2. Okay, so this is inside the larger square root. We choose plus because we're looking at 22.5 degrees, and that takes us in the first quadrant, so we know that we're not going to use the minus for sine there. Okay, so that's all I wanted to look at 7.3. We'll look at an example in class, maybe using a cosine, but I just wanted to show you a couple things inside 7.2, 7.3.